Hey everybody, it's Steve. I've been having Claude port a TypeScript algorithm from TypeScript algorithm to Zig. The algorithm is a slight modification of the Clark-Wright algorithm for the capacitated vehicle routing problem. The basic premise here is that you've got a bunch of houses in a fictionalized version of Seattle that have placed orders for delivery from a warehouse. Let's say these are like grocery totes or whatever. The warehouse has a total of 8 trucks and needs to send out the trucks to the various neighborhoods. And of course, you want the trucks to mostly concentrate their effort in certain areas of Seattle, so that you don't have every single truck driving all over Seattle delivering to random homes. You can see that we've color coded the homes that each truck goes to. This is the version here in TypeScript, and I'm about to show you the version in Zig, and I am testing it because Claude wrote that, and now I need to test it. So this is running on my local host here on port 9001, and I am just going to start uh, verifying that the program still works. First thing I'm going to do is just make sure that it's actually running WebAssembly. And if I go here, um, I can see that it's running WebAssembly. I don't know. I'm not going to like actually be able to step through any of this code, but I'm confident that I'm actually running the new version. So let's see. One thing I can do here. This is showing shift S1. So every shift is like a shift where the trucks have to go out and deliver groceries. And so on the second shift, they might have to deliver a different set of orders. So when I hit S, it does a random shuffle. I'll hit S a couple times and keep your eyes on the orange. Every time I do a new shift, the orange truck, which is truck 2, uh, has to make deliveries to a different set of homes because the homes on each shift, different homes make orders on different shifts. The next thing I'm going to do is just animate the trucks going out and making the deliveries. Speaking of the orange truck, that little orange dot there is making the deliveries to Fremont, and then Queen Anne Hill, and then Magnolia, and all the other trucks are making the deliveries. This particular animation isn't really that doesn't really illustrate a whole lot other than that the trucks make the deliveries in roughly the same amount of time because the deliveries are equally distributed among the trucks. That's not necessarily like always the behavior, and we actually give a head start to the truck that requires the most time. So you see the orange dot goes out, and then the green, and then the purple, and then those trucks are staggered because it would just be completely impossible and impractical to have every truck have the exact same delivery time. Some trucks have to go out west from the warehouse, which is in the east, in order to make it. But so far, I haven't found any apparent bugs. I'm going to do another shuffle with S just to make sure all of these things look pretty similar. And in fact, if I go over to the prod version, I should see the exact same seeding when I get to shift S7. So the orange truck should be making 5 deliveries in Magnolia, 4 in Queen Anne Hill, and then another 5 in Fremont. So you can see the TypeScript's actually a little bit slower for the shuffle. And here I am on shift 7, and the TypeScript algorithm had also decided that there would be 5. The truck 2 would pick up the 5 from Magnolia, the 4 from Queen Anne Hill, and the 5 from Fremont. Now going back to the localhost version, again, the localhost version is running the Zig web assembly version of the algorithm. You can actually step the solve here with A. So I'm going to hit the A key. And now I can just forward through the algorithm, and you can see that it is animating essentially the Clark-Wright algorithm, which basically is deciding which clusters of homes go into the trucks. Um, and so Claude seems to have ported that faithfully as well. And I will show you some of the dialogue that I had with Claude recently. Let's see. So you can see here I said go. That wasn't at the very beginning, but Claude essentially did all of this in one shot and just paused to write me essays about what it was going to do. And basically, I signed off on all the plans. Claude and I have done a very similar port of TypeScript code to Zig in the past, so I had a lot of confidence in its ability to do that. And I did, and so then it said the swap is done. Delivery on localhost now runs the SIG solver as WASM end to end, and it gave me a right up here, which I'll show you real quick. So it says the swap is in / delivery runs the Zig brain, and you know it gave me some details about what it did, including some ouches that it observed along the way. Not really important for this video, but you can show that Claude is kind of doing due diligence to tell me anything that I might want to be notified about. Then I asked, what's the easiest way to verify that the local version is actually running Zig? Because I didn't want to sign off on the Zig port and find out that I didn't hard reload my browser, or that I failed to hard reload the browser, and I was actually just verifying that TypeScript is doing the same thing as TypeScript. So it gave me it gave me it's not showing it here, but it gave me a kind of a structural proof that it's running the Zig, because there are some minor differences in like the caption text that you'll see. Maybe I can actually even see it in localhost. Algorithm. Consolidated and only so when you press A and see start 26 clusters seeded, that ticks. I'm not seeing where it says 26 clusters seeded, so that's a little concerning. Create a new shift, hit A. Oh, right here. Okay, yeah. So what you see, 25 clusters seeded here, that was never in the TypeScript version. And so if I go over here and hit A, it does say 25 clusters seeded. So I need to challenge. The structural proof is what you just saw. The solver strings, pane of, and caption tests like cluster seeded appears 0 times in the served app.js and only. Oh, okay. So this is my bad. So what Claude did to verify that the Zig code was running on the local server is Claude did essentially a curl using, curl does like an HTTP request to the server, and Claude was able to verify that certain text was never served in app.js, but only served in solver WASM. And if I take Claude's word on that, combined with the fact that I still do indeed see the text, that's useful. But the more important thing is that it told me to actually look at the WASM. So when I hit F12 to go into the debugger, I can actually see that the WASM is running right here. Importantly, there is still some JS running in the code, because JS is still responsible for like actually drawing the map. It's just not running. It's just not running the actual solver algorithm, which determines how that trucks or how the houses get allocated to trucks. But anyway, I think I'm gonna stop there. Oh, I asked how do I see the sources in Firefox. Oh, and then I asked, I still see a lot of code in app.js, including things like draw bridges. I guess I'm still not completely clear where the JS boundary lives. And then Claude makes it very clear to me where those boundaries lives. Decisions cross to Zig, Pixel State, and TS. So TS is now just a very dumb drawing program, and all of the actual important logic of routing the trucks is now in Zig. And it does point out this interesting subtlety here. It says one subtlety one subtlety worth naming, the geography and road graph code exists on both sides now. The WASM needs it to decide, JS needs it to draw. That all makes perfect sense to me. So I think I'm going to wrap it up here. This is the end of me porting. Let's see how many lines of code. So yeah, Claude wrote about 3,000 lines of code this morning, and it's not even noon. All right, enjoy your day.